Guys, we can start now.
Good morning, everyone. I am Bhargavi from CRC second year. I welcome you all to the Technoviz event. Now, Sarthak Tyagi of CSC second year will give a welcome speech.
Thank you, Bhargavi. Machine intelligence is the last invention that humanity will ever need to make. These were the words of famous Swedish philosopher Nick Bostrom, which will appear to be true in the near future. With this thought, I would like to welcome all the faculty coordinators and my dear friends to the Technoviz event organized by our club Tech Vayuna, which will take you through the deep insights of machine learning and will enlighten you with some amazing stuff regarding machine learning. I would like to welcome ex-SRMite Mr. Eben Verghese, a machine learning engineer and a corporate trainer in data science and machine learning track at Infosys. He has specialized in software development and data analysis methods using Python, classical machine learning, and statistical analysis. He has also made courses on classical machine learning, deep learning, GPT-3, etc. So, without taking your any time, I would like to invite Mr. Eben Verghese to kickstart this exciting webinar on machine learning.
Yeah, thank you for having me, team. So it's to be honest, it's a very weird and wonderful feeling to come back as an alumni to my college. Although I graduated from SRM NCR campus, so yeah. Anyway, we all are one family. So yeah, thank you for having me again, once again. So today I'm going to speak about decentralized machine learning and so on and so forth, and I will explain why I selected this particular topic only, because it is, in my opinion, it is going to be of a huge importance in the near future. Okay, so yeah, let's start. I hope I'm audible, so we can begin. Yeah, just a second. Uh, I'm going to share my screen and I'm going to start the presentation. All right, so today we are going to talk a bit about decentralized machine learning and private AI. So why did I really choose this particular topic only is because essentially we almost all of us know what machine learning is, or at least we have some general idea what that is. And to wit, I thought that maybe it is my not only privilege but also a duty in some sense to present to you what what would be useful for you as students from an academic perspective and also from an industrial perspective. So that's why I'm going to talk about private AI, because it's relatively a new area of research as well. So if some of you may want to go into, let's say, research side, private AI is not only very lucrative in the sense that they are you can actually work on to solve some really core elements like that are actually bugging the machine learning in industries, but also there are very since it's fairly relatively new area, there are also a lot of low hanging fruits, right? So with that being said, so these are the table of contents, right? So I'll first introduce you to what machine learning is, and to be honest, I'll be speaking about unsupervised machine learning only, and then I'll proceed with why. I mean, what are the problems that are actually that are actually bugging us in the industry, and how could we solve it? To it, I will introduce you to something called private AI, and then I will talk to you about decentralized machine learning, and followed by federated learning and differential privacy. And towards the end, I will talk about career pathways. right? So let's begin. So what is machine learning? So before asking that thing, I think it is imperative to understand what programming is. And I guess most of you will agree with me, programming is nothing but the ability to teach machines to do certain tasks based on instructions, right? So those instructions are called code in some sense, right? Uh, so that's like fairly a simple, I mean, a very naive and very simple, very basic definition of what programming is. So now, if I'd ask you what is machine learning, well, to be honest, I mean there are different definitions on the internet given by different people, scientists, and pioneers what machine learning is. But I particularly love Cassie Kozikos, who is Google's this chief decision scientist. Her definition of machine learning. So if you remove, I mean, machine learning is nothing but the ability to teach machines to do certain tasks based on examples. So instead of, let's say, hard coding the program, hard coding the actual code into the machine to do certain tasks, we will give the machines the ability and the leverage to learn, to find certain patterns among the data and learn from them. It is akin to sort of like it is akin how a baby learns around its surroundings and so on and so forth. So in other words, the baby or the machine will actually look at a lot of examples. So let's say there's a image of a cat and a dog. Yeah, so it will sort of look at, let's say, thousands of images of different cats and different dogs, and it will try to find out, okay, these are the general patterns that are in the dogs and these are general patterns that are in the cat. So probably if such features are present, probably it's a dog. So for like example, if there is a long snout, okay, so out of 1,000 images of dogs, let's say 900 of them had a long snout, okay, so then probably a brand new image with with an animal having a long snout, probably that is a dog. Same goes for cat. If there are pointy ears and whiskers, probably it's a cat. I don't know. Just telling you, just like how a baby learns stuff. So that is machine learning. Like we as developers are trying to teach machines to do certain tasks and to find some patterns among them. So to it, I will give one very good example from my own life of unsupervised machine learning. And I guess this example should make everything clear to you. So this is something called unsupervised machine learning. Okay, so what on earth is unsupervised machine learning? What are we trying to do? Well, as the name suggests, unsupervised machine learning don't have any labeled data, or in other words, let me give you an example. Okay, so back in Jan 2020, when I went to Mysore for my Infosys training, in my batch there were about 192 trainees, with me, along with me. Well, back in the days we were called interns, not really trainees. So yeah, so obviously I can't show 192 interns over here on the screen. So I just randomly selected 15 folks from my class, and I asked them, and I'm asking you as a developer, hey, these are the 15 folks. So to me, all those 15 folks look identical to me. I mean, these tiny dots, these tiny orange dots are those interns. And I'd ask you, based on, let's say, two interests, philosophical discussion and interest in football, how likely are certain people, how likely are that some people will stick together? Or, can you find me, what people will stick together or are more likely to make good friends with each other? So I'm not sure about you, but I guess, friendship begins, the bond of friendship begins when if there is a mutual connection and mutual understanding and mutual interest. So I think that so you know what, so it is your job as a data scientist to find that out. So you have a data set and it is unlabeled, you don't know anything about the data set. So what you'll do is that, okay, so you will try to define certain parameters, and based on those parameters, you will try to find out, okay, what is happening exactly. So let's say on x-axis I'm telling that this is the interest in football, and on y-axis I'm giving that in an increasing order, interest in philosophical discussions. Philosophical discussions like maybe someone like to discuss, or maybe talk about philosophers like Nietzsche, Jung, Dostoevsky, or John Peterson. I'm just giving you an example. I don't know. It could be anything. Okay. So when I asked you to do this thing, and when I asked these 15 people, you know what, based on your interest, spread out on this plane according where you want to stand. So when I asked them to do this thing, they spread out somewhat like this thing. So let's take this particular person in our case. So this person is interested in football, and could be watching football or playing football, and this person is also interested in has very high interest in getting himself or herself involved in philosophical discussions. So that's why this person came here. A high value of x-axis, that is high value interest in football, and high value in interest in philosophical discussion. So when this person came here, this person noticed that there are two other people who share his or her interest as well. And I would say, okay, so they are more likely to hang out together more, and maybe just saying that, more likely to stick together. That's why maybe more likely to remain friends. Excuse me, is someone trying to speak?
No, sir. It was someone by mistake, I guess. You can continue.
Okay, all right then. So I don't know. I'm just telling you that if you're like me, if you're someone like me, then you would probably be lying in this category, in this cluster. So I personally, have a lot of interest in philosophical discussion, debate, and all. But to be honest, I don't really like football. In the sense that I will only watch football, or let's say, to be honest, I don't even watch football. I only see the news, and okay, these are the score and El Clasico. Okay, I'll just watch the highlights just to be included in talks with my friends. That's it. I really don't care about football, to be honest. So if you're someone like me, if I'm here, then I will notice that, okay, three other people are also similar to me. So that means that we are also, we are going to stick together. Same goes here and here as well. Okay. So I think you can appreciate the fact that they are sort of forming a cluster. Okay. This is a classic example of clustering algorithm or unsupervised machine learning. So this is like what machine learning is. I did not tell my computer that these are the things, these are the codes, the instruction that you have to follow. No, I didn't do that. I gave the machine the data set, and I coded, let's say, programmed some parameters, and let the machine find out for itself the pattern among the data set and come to a conclusion. That's it. Right, so I try to teach machine using certain examples and so on and so forth. So this is like an unsupervised machine learning example. I hope that was clear. And and to be honest, I just picked one particular type of machine learning. There is something called supervised machine learning, reinforcement learning, and so on and so forth. So I don't want to pick that up because there are plenty of speakers who can speak on that, and I don't want to repeat. Probably some of you already know what these things are. Now comes the interesting part, that what is wrong with machine learning in industries in today's date. I think the main concern, I won't say the problem, I think it's an opportunity in a business opportunity and an academic opportunity to solve some problems, is the privacy part. So I guess I don't think I should mention, or I should introduce you what Cambridge Analytica was, or those things were. So you could say that privacy in AI is a huge concern right now. So one of the main problem or challenges in machine learning is that we can only teach machines if we have a lot of data sets or a lot of examples. But if someone is not willing to provide their data set, their information, because due to privacy concerns, how on earth will I train my machine learning model, let's say? And Now that's a conundrum. How to do that? How to solve this part? I mean, I don't want to give my data to you, and you want my data, let's say, and to train a machine learning model. Well, that is something that we're going to discuss today, and to be honest, it's really interesting if you ask me. So before we talk about all that, let me tell you what exactly is privacy. Lucky for me, I don't have to come up with some brand new definitions. Solving a privacy problem doesn't necessarily need to be a privacy tech tool's primary concern. So examples of these are Signal and DuckDuckGo products, which are primarily browsing, searching, and messaging tools that are built with privacy as a key differentiating feature. So the privacy tech landscape might be nascent or very new from with regards to funding and market viability standpoints, but privacy tech is the culmination of decades worth of developments from privacy academia and thought leadership, the privacy regulatory landscape. So what I'm trying to say is that privacy tech is not the same as cybersecurity tech, but they do intersect. So let me give you an example. So let me give you an example that how is privacy. So this is like the privacy tech thing I told you about. So let me give you an example that how privacy tech is not the same as cybersecurity, but make no mistake, they do intersect. But privacy is a huge umbrella under which cybersecurity comes. So the information privacy and security, these two domains intersect with each other, but there's also a clear distinction between the two. So let me give you an example. The two domains intersect where information privacy requires that personal information must be secured during its entire lifetime. So from collection and use to transfer, storage, and destruction.
Hello. Hello, sir.
Yeah.
Share screen sharing, not coming.
Actually, the screen is coming, sir. You just carry on. Please check your network. Participant, please check your network. The screen is working. So you can move on.
Screen share is not coming. That's why.
Oh, really? Can any of you confirm? Is that there's the problem?
Sir, your
from
screen is still.
No, screen sharing is visible. Can you please pin the screen? Maybe it's in parts.
Pin the screen, okay.
I mean, your screen is visible, so no problem.
Okay.
Yeah, you can continue.
All right. So yeah, if you have any problem, you can speak up. Maybe we can solve. We can solve this thing. So yeah, let's continue. As I was saying that privacy tech is not the same as cybersecurity. So let me give you an example. I mean, what is the main difference? So privacy is one huge umbrella under which cybersecurity comes. So there are existing bodies of literature defining privacy and security. So I'm going to refer back to the complex and multifaceted conceptions of privacy that encompass the individual control, trust, obscurity, power, context, and anonymity. Whereas information security or cybersecurity is concerned only with the confidentiality, integrity, and availability of information. So, in other words, you could say that, given privacy's breadth of inquiry beyond security, the privacy and security conflation is oftentimes as indicators that a self-proclaimed privacy tech company may not understand privacy. So in other words, all I'm trying to say is that, cybersecurity is only concerned with, let's say, encrypting your data and so on and so forth. But privacy goes beyond that and try to answer certain questions like, what exactly is information flow? From where is the information coming from to where it is going, so on and so forth. I'm just giving you, it's very abstract thought. Another thing is that privacy is not anonymity, but again, it overlaps with anonymity, which privacy tech overlaps with and covers anonymity tech. So regarding this thing, I'll give you a really good example about Netflix, and it will blow your mind, trust me. So, but privacy by no means is anonymity. Is not anonymous. So anonymity is an incomplete take on privacy. In a few moments, I will explain what that exactly is, what I really mean, that even if you're anonymous, you can still be traced. I'll give you an example soon. So under the privacy as choice under the privacy as choice school of thought, privacy covers other individual choices and exercises of power over personal information beyond the choice to remain anonymous. Anonymity is merely one way to exercise privacy choice, but it is an incomplete take on privacy, but still an important aspect of it. So again, privacy tech is neither privacy by design nor privacy engineering, but if you're going to, let's say, start your own gig or start your own company, you have to focus on privacy by design and privacy, by in engineering also. So you have to keep the design, privacy engineering and privacy by design both, coherent with each other. So what exactly privacy by design mean? So it basically means that it basically covers the following set of design principles, like you have to be proactive and preventive, not reactive and remedial. You can't be like, we won't care about it. We will only react to a certain problem with regards to privacy. You can't be doing that. You can't be doing that. It should be ingrained in your solutions in a very proactive manner. Privacy as the default setting. Whatever you do, let's say you're starting out your own company or you're working for, let's say, Microsoft, and your solution must be private. The privacy must be a default setting. Privacy must be embedded into design, and it must be end-to-end secure and also visible and transparent. And I guess the most important thing is probably you should have a respect for the end user as well. You must be respecting their privacy concerns and so on and so forth. So in other words, you could say that privacy by design articulates these goals for privacy design, but the problem is it does not tell how to reach it. It tells that, okay, these are the principles that you may want to keep in mind, but how to reach that? The solution is that privacy engineering provides a discipline for achieving privacy by design principles. So I talked a lot about privacy. How would we do that? I mean, you mentioned about these things, like we have to create a end-to-end secure, transparent privacy thing in our privacy software. You have to integrate that thing into our let's say project and all. But how would we do that? Well, to it, I'm going to give you two examples, which are called Federated Learning and Differential Privacy. Okay. So let me give you an example of Federated Learning and Differential Privacy. I'll walk you through it. So I hope you can see my screen. Okay. All right. So what basically this really means is that as the data grows, okay, so the accuracy will saturate. So now the problem, as I mentioned, that to increase the accuracy, I think you would agree with me that you will require more and more data. I know that after a certain point, it will sort of plateau out. So no matter after that point, no matter how much data you feed to your model, it won't improve the accuracy. But at least to get there, you need a lot of data. And what if the user is not willing to provide the data because your data is centralized on a server? So right now, the current version of machine learning is something called centralized machine learning. Or in other words, you could say that your data and my data, let's say, is stored on a server. And that server is located somewhere on this planet and is owned by a company. I know, legally speaking and on paper, the data belongs to us, but it is stored on their servers. So if at all, on paper, I'm just telling that if at all the company goes rogue and decides to use your data against you, I guess Facebook has been doing that. I won't deny that. What's to stop them from, who is going to stop them, and what is going to stop them? Well, the answer turns out to be decentralized. Instead of centralizing our data onto a server, what if we can reverse the process? Let me give you an example, okay? And it's going to be really interesting. So I hope you understood the current version of machine learning is that we will provide our data to let's say to Google, and the Google will sort of make some predictions based on our data. So for that thing, the data has to leave our devices and has to migrate to their servers. And on their servers, the machine learning models will operate on your data and will do the magic, let's say that. Okay. Now the solution turns out to be something opposite of it. That is called federated learning. So let me give you an example. Okay? So let's say this is the cloud, let's say Google Cloud, and these are your individual devices. These are called edge devices. What federated learning does is that, I mean, your individual device will have certain data. So these tiny, tiny dots are those data, which is residing on your device, on my device, and on someone else's device. What happens is that the machine learning model will deploy. So there was an initial model that was deployed on the cloud. Now, what happens is that instead of migrating the data onto the server, what happens is that this this initial model will be deployed on your individual devices, okay? And then it will sort of, it will so your edge device will download the initial model, and based on your personal data, it will make some changes. It will make a local update. Okay, so this thing has this blue line changed to yellow line. Okay, something like this thing. And then this local update, only this local update will be sent back to the cloud obviously in an encrypted fashion, so that there should be no man-in-the-middle attacks sort of thing. So this is something called federated learning, okay? And then based on the local updates, all the local updates, and a new model will be averaged and will be created, or let's say updated in some sense, right? So this is completely opposite. In doing so, your data never leaves your device, and my data will never leave my device. Your data will stay with you, and my data will stay with me, and only a local update, a learning will be sent back to the cloud. In other words, I'm trying to say is that, if I want to find out that does smoking leads to cancer, I don't need to know. I don't need to particularly find out, do you smoke or not? I mean, based on some evidences, I know, okay, I will get the learning, the model update, I will learn, okay, smoking leads to cancer, but I don't have to individually find out, is this person a smoker or not? So in other words, the privacy, the privacy of the individual remains secure. So this is something called decentralized machine learning, because your data is distributed across all the devices. Hope it makes sense to you. I don't want to. I hope I'm sort of making some sense to you. All right. So what are the use cases? Well, to be honest, if you are using Google Keyboard, you're already using federated learning. Okay. So one of the first applications of federated learning was to improve word recommendation in Google's Android keyboard without uploading the data. So if you use my phone, the keyboard, it will recommend some certain set of words, and if I use yours will be different recommendations. So that's based on, because your data is sitting on your device and my data is sitting on my device, and the local model was downloaded, made some changes, and then the update was uploaded onto the cloud, so that the model can improve the efficiency. So that way your data remains with you, my data remains with me. So it's I think it's really important. It's really insane to to preserve the privacy in this fashion. So keeping the data at its source is valuable in any privacy preserving application, especially like in applied, especially in healthcare or in confidential data in business and government. So this is something about federated learning. So what are the advantages? I guess the advantage is very obvious, that researchers can train models using private and sensitive data without having to worry about handling the data. And the data remains on the device, and only learned model updates are transferred between the lab and the data owners, right? So that's an advantage, right? So privacy is preserved in some sense. What is the disadvantage? The truth is, federated learning is not cool. I mean, let's say is not perfect in the sense that the cost for implementing federated learning is higher than collecting the information and processing it centrally. It is going to cost the company more. It requires data owners to perform computations on their local devices. So that means, in some sense, your edge device has to, do extra computation, has to reserve some space for it. So that may come where, when some, time and space, it will take some extra, space in your local devices. So that's like one disadvantage, you could say. So for some devices with limited computation capacity, this may not be possible also. Again, and one last thing, implementing federated learning is not enough to guarantee privacy, as model updates may include traces that can be used to infer private and sensitive information. So that could be possible that even if your your local update is sent back to the cloud, it is possible that that update may contain some traces of you, and it could be used to trace you back. So it's not perfect in that sense. So this is where the differential privacy comes in, that, okay, federated learning is all cool, but how would we actually, I mean, if someone can still trace me back, how can I tackle that thing? That's where your differential privacy comes in. Okay. So I hope you're with me so far. I hope it makes sense to you. You're interested in this thing. I mean, to be honest, this is, if you're like planning for a master's or a PhD, these are some low-hanging fruits, and you may want to have a look at this thing. Could be in academia, or like even if you want to, let's say, start your own gig and start your own company around this thing. I think there's a huge market out there waiting for you. So that's why I selected this particular topic, only because a lot of people don't talk about it, and it's very, eccentric, you could say. Now coming to the part, differential privacy. So differential privacy aims at addressing the paradox of learning nothing about an individual while learning useful information about a population. So I gave an example. If there's a population of people who smoke cigarette, I don't have to learn individually about let's say a particular person who smokes to find out that smoking leads to cancer. So that is the beauty of it, that you can learn about the population in general without invading the privacy of an individual. And that is the beauty. So in a sense, it describes the following premise made by data holders. So let's say, I'll give you an example. Okay, let me find out. So this is an example on your screen right here. So in this particular data set, there is a green, data here, data point here. Let's say he's John. Okay. So this database, there are two databases, database 1 and database 2. In database 1 and so the database, the number of records in database 1 and database 2 differs by 1. So in other words, I'm saying that in database 1, there in the population, John is there, and in database 2, exactly the entire population is there, but without John. So this database contains John, and this database does not contain John. So if there are 100 records here, so including John, this database will include 99 people because John is missing in this case. Okay, so considering this illustration where the two databases, database 1 and database 2, differ by only one record, say your data, let's say John's data here. So if the results obtained from querying the database under these two different settings are almost same or similarly distributed, they are essentially indistinguishable to an adversary. Or in other words, I'm saying that in this database, if I'm, let's say, doing some query, doing something, let's say I'm trying to, let's say there's a database of salaries, okay? And I mean, these two databases of salaries, I'm saying that if I take the sum of all people's salary, let's say after summing all people's salary, I will get an answer here. So the query that I'm going to run is sum all the salaries here. So I will get some, let's say each person, let's say there are 3 people. This person has an annual income of $100,000. This person has $50,000 and John has about $200,000 of income. So when I do the query, I will get the sum to be about 200 plus 100 plus 150. That makes about $450,000, the total. And and since John is missing here, the answer here would be 100 plus 150. That is about $250,000. So I'm saying that if I compare both the results of the two queries, me as an adversary can find out the salary, which is a sensitive data of John, even though John did not participate in this database. I mean, John's information was not there in the database. I hope you can understand the difference. That but this is something like linking attack. Okay, I'll explain that in a moment. So even though John did not participate in this data set, I could find out the salary of John by comparing the two data sets. The difference will be the two data, will be his salary. Now I'm saying what differential privacy does is that the differential privacy will add some noise to the data set, to both the data set. And when I compare it, in the end, if I'm unable to find out the sensitive data of, let's say, the missing person, I could say that, you could say that that it doesn't matter if John participates in this, in this database or not, because with or without him, the answer is remaining the same. Or in other words, if let's say if the participant, let's say this is a differentially private data set and this is also a differentially private data set, I'm saying that if on summing up, I'm getting an answer, let's say $700,000. And here also I'm getting somewhere around close to $700,000, let's say $710,000. I'm unable to understand that how much is John contributing exactly. So I'm unable to find out, right? So in other words, the privacy of John remains intact. That is the power of differential privacy. I hope it made sense to you. I'm not sure how much of I know this is like very involved stuff, but again, if you're really interested in this thing, you can learn about it more. So that's an introduction to differential privacy. So let me give you an example of what exactly it is, how important privacy is. So I guess it was in 2006 or 2007 that Netflix announced a Netflix prize competition. So what happened there was, so the Netflix prize was an open competition for the best collaborative filtering algorithm for movie recommendation. So in other words, if you watch movies on Netflix, that it collects the data that based on your already watched movie, it will recommend you new movies, right? So what Netflix decided was, they will launch a open competition to everyone, where they will anonymize your name and each individual's name, and I guess they also anonymized or let's say encrypted the movies that you watched, right? So that way you would think that you can't be traced back, your privacy is intact in that sense. Well, so what they were looking for, like, can you develop a recommendation engine which has a high accuracy? So that's what Netflix did, but there were two people from the University of Texas, Arvind Narayanan and Vitaly Shmatikov, who did something called Linkage Attack. So your data on Netflix was anonymized. Okay, that would have been perfect. But there is something called IMDb as well. So in IMDb also, after watching movies, people can sort of people can go and rate the movies. So it turns out, let's say today, if I'm watching Fences on Netflix, I will rate let's say 10 on 10 for Fences on Netflix, and my data is anonymized, obviously, but I will go and also rate the movie on IMDb as well. So, and the IMDb data is public and is not anonymous. You can see who voted for which movie and how much. Now, based on these two things, Arvind and Vitaly were able to connect or link the anonymous data on Netflix, anonymous Netflix data with the public and incomplete IMDb data, and they were able to, with a very high accuracy, they were able to track that which movie Alice liked, which movie different individuals liked. This is something called your linkage attack. So I think you have understood that anonymization is not enough to keep your to preserve your privacy. So it's a huge thing, and it was and to be honest, Netflix were also sued for this thing. It costed the company a lot of bucks as well. So differential privacy aims at neutralizing such linkage attacks, as differential privacy is a property of the data access mechanism and is unrelated to the presence or absence of auxiliary information available to the adversary. So therefore, access to the IMDb would no longer permit a linkage attack to someone whose history is on the Netflix training set than to someone not in the training set. So all I'm trying to say is that, differential privacy is really crucial in some sense. That's what I'm trying to summarize. So what are the use cases? This is like one use case Google uses is, to make differential privacy effective, you need to have a huge data set. So that's why company like Amazon, Google, and Apple, or let's say the US government, are there, since they have a lot of data set with them, they can use it. And I personally think that if US government can use it to anonymize the census of the population, I think India can also do that, because I think India will have a huge, much greater data set compared to the US regarding, and I guess it's important as well for to preserve the privacy of our citizens as well. So this is one use case that the Indian government can apply to preserve the privacy of their citizens' census data. So this was one example of differential privacy. Let me give you, before telling you the career pathways, what you can expect if you want to go into the industry. Let me give you a walkthrough of the differential privacy. So here I have already imported and done all the coding here. So I've already executed it. So I hope it's clear to you, it's visible to you in a good fashion. So I'm going to illustrate differential privacy using a package called Python DP or PyDP. Okay, so I'm going to import it. So I've already imported the thing. So huge. I did not mention a lot of stuff in differential privacy about the privacy budget and all, but I guess this should be enough for you to get started. So PyDP is an open minds Python wrapper for Google's differential privacy project. So this library provides a set of epsilon differentially private algorithm. Forget what that is. Which can be used to produce aggregate statistics over numeric data set containing private or potentially sensitive information. So let me give you an example. Okay, so I imported certain data set from here. Okay, so if you go to this link, you can find the data set. So all you have to do is visit this link. Okay, so the data set used here contains 5,000 records and is stored across 5 files, each file containing 1,000 records. More specifically, the dataset contains details such as the first and last names. You can see the dataset, email address of customers, and the amount they spent on purchasing goods, and the state in the US they're from. So let's fetch all the records, read them into pandas data frame, and take a look at the head of each record. So these are the DF1, data frame 1, data frame 2, 3, and 4. Okay, and also 5. So now that we have fetched records from all the 5 files, let us concatenate all the data frames into a single large data frame, and this constitutes our original data set. So we are going to concatenate all the data frames together. Now and we will get an original data set after concatenating. So we are expecting there to be 5,000 records and 6 columns. And that is the shape that we're getting. Okay, so far so good. Let us now create a parallel database that differs by only 1 record. So let's say Osborne's record and name is removed, And after removing Osborne, we are storing the data set into a new data frame called redact dataset. Okay, so Osborne was the first, hang on, I guess Osborne was the, yeah. So Osborne, so in our original data set, Osborne is the first entry. In our redact data set, we are going to remove the first entry and we are going to understand this thing. All I'm trying to do is that now, let's see. So at this point, let us ask ourselves the following question. Is the amount of money we spend at our neighborhood store private or sensitive information? Well, it may not seem all that sensitive, right? But what if the information can be used to identify you? Then what? So based on how much you've spent on a certain store, what if you could be identified? Now this sales amount is a sensitive information or private. Okay. So in the example that we have, let us say we remove all personal information such as name, first name and last name, and email address. So given that there's some access to the store's sales record, and my question is, will the sales amount in itself not suffice to infer Osborne's identity? So given only this column, can you identify Osborne? That is my question. So only this column. So let's remove the first name, last name, and the email address. Can you still identify Osborne? The answer turns out to be yes. Even after anonymizing or removing this first name, last name, and the email address, your data set is still not private. So to do that, let us sum up. I gave you an example summing up, so we'll do that again here. Let us sum up all the entries in the sales amount in our original data set and the redact data set. The difference between these two sums exactly gives the amount that Osborne spent and is verified in the given in this particular code. So after so whatever the difference would be, you will that will be the amount that Osborne spent. So I'm going to do some calculations and I'm going to store Osborne's information based on the difference in sales amount Osborne variable. Now introducing differential private sum. So I'm hoping that using differential privacy, I'm hoping that after adding some noise to the entire data set and so on and so forth, I'm going I'm hoping that I should not be able to identify Osborne's Osborne's sales amount or how much he spent. So here Osborne, you have to remember that Osborne spent $31.94. So on finding the difference, you will find out that exactly $31.94 is missing from both the sales amounts. So that is probably what Osborne must have spent. So that's how you can identify Osborne. I'm hoping that after applying differential privacy, the difference should not come to be 31.94, or it should be different from that. So let me try to illustrate that thing. So differentially private sum. Now I illustrate how differentially private sum in place of simple sum can help in rendering membership inference attacks unsuccessful. So for example, in this particular example, let's assume that the customers should spend a minimum of $5 at the store and no more than $250 for a particular purchase. So I'm going to give it a budget in some sense, right? So I'm going to give it a lower limit and an upper limit. That is called, and then I will bound the sum. So we'll go ahead and then compute the differentially private sum. So the differentially private sum is something like this thing. Just a second. Yeah. So my original sum came out to be 636,702, and my differentially private sum is coming out to be 636,617. So here you have to find out that. A second. So both these sums are quite different. Clearly, both of them are different. So let me try to summarize a few observations. Now that we've calculated the differentially private sum on the original and the second data set, it is straightforward to verify that the differentially private sums are not equal to sums under the non-differentially private setting. Also, the difference is no longer equal to the amount that Osborne spent, indicating that membership attacks would be unsuccessful from now. So interestingly, the differentially private sum values are still comparable and not very different. So we have therefore succeeded in ensuring differential privacy in our simple example. So let me see. Yeah. So your actual difference, if you remember, was $31.94. If you recall this thing. So without differential privacy, I was able to find out. So the difference was Osborne's how much he spent. But after applying differential privacy, it is coming out to be 84.95. So even if I'm trying to identify this thing, it will give me 84.95, which is a wrong information, and it will lead adversary to a wrong conclusion. So in that way, the privacy of Osborne is preserved. I hope this illustration was good enough for you to appreciate the power of differential privacy, and you can have for more similar stuff, you can actually go out and find out on Google, and you will get a lot of stuff on differential privacy. So if you want to go into research side, this is some a new research area, and I would encourage all of you to have a look at it. So that was an example of differential privacy and an illustration. I hope it made sense. Now I won't. The time is almost up for me. I'll take another 5 to 10 minutes to for folks who want to go into industry, or let's say who are in their third or final year. What exactly are the career pathways in AI? So before moving on, I want you to focus on this particular slide. That I want you to focus on this thing. There are certain conclusions that you can find out, that different companies have different, let's say you have X amount, X data set, X skills. Different companies will require, for the same job, will have different job titles. So I don't know, Amazon is calling you machine learning scientist, Google will call you machine learning analyst, so on and so forth. So the purpose of this slide is that even since it is still maturing, this AI thing is still maturing in the industry, companies they themselves are not sure what they are looking for, if I'm being absolutely honest. So that is why they will require, since you're meant to be dealing with you're meant to be dealing with huge amounts of data set, they don't want to hire any rookie, or let's say anyone who's like junior in some sense. So that is why I think that could be one contributing factor why companies require you to have at least a master's degree. I don't know how master's degree translate to your maturity in handling data, but I guess it does in some sense that to do masters you have to spend a lot of time and invest a lot of energy to learn certain skills, and I guess that could translate. And I think that is the closest thing that the companies have come up to identify someone, is this person a good fit or not. So that is why in AI and data science, 90% or majority of them, I'm not kidding, 90% of them have at least a master's degree. But with that being said, it is not unheard of people jumping into data science with only a bachelor's degree. So again, I'll leave it up to you to make a decision here. Now coming to the fact that what are the job roles of a data scientist, machine learning engineer, software engineer, machine learning, and machine learning researcher. And all. You have to understand that in the industry, you will be mostly doing the programming stuff. Okay, so programming skills are a must for everything. Maybe not for so much for researcher, but I have clients have come up to me who were in research side who required programming skills anyway. So programming is absolutely important. So that's why data engineering part is an absolute must. So when I say programming, you must have Python skills. SQL is probably at the top. You need to be really comfortable using SQL. It could be any SQL, MySQL, PostgreSQL or anything. I'm not really concerned about that. I mean that's beyond the scope of this discussion anyway. But you need to have really good programming skills and query skills as well. So these are the things that, so if you're, let's say, data scientist, you will be required to work on data engineering, modeling, and business analysis. So, I mean, you need to have a niche and you need to have a lot of domain knowledge to be successful in as a data scientist. All I'm trying to say is that you could be a really excellent data scientist in, let's say, tech. Doesn't mean that you will be a really good data scientist in healthcare. Yeah, so you need to have a domain knowledge there as well. Same goes, so similar thing goes for data analyst, machine learning engineer. So you're more concerned with, say if you're a machine learning engineer, you're more concerned with data engineering, modeling, and deployment, so and if you're, let's say, an architect, so you're more concerned with, let's say, software engineer who's intertwined his work with building building the entire system, then you may want to have some system design knowledge as well to build the infrastructure also. So these are things. So these are skills that are required. So we can have a look at this thing. So if you're a data scientist, you must be having software, to be honest, software engineering should also be there. But majority of things like required for business acumen, mathematics, machine learning. And don't be fooled by this thing. You also require software engineering part, but you are not required to build an infrastructure. You're not required to build a system. So that's why that's why it is mentioned that it is 0 probably, but you need to have algorithmic coding experience. So that includes your programming skills and scripting and SQL skills as well. Similar thing goes for your data analyst. So let's say if you want to become a data scientist or machine learning engineer, my strong recommendation would be, and you don't want to do masters, let's say, you're fed up with studies, what you can do is that your best bet would be to find a job role that is closest to data science. So that could be data analyst or a software engineer. Get into a company as a data analyst or a software engineer, and then from there you can switch to data. If the company has a data science team or something like that, you can switch it, because an internal job shifting is very easy to do compared to hiring someone from the outside. So if I want to, if someone is already there in Infosys, it's very easy to move into a data science track compared to someone who is outside of Infosys. And when I say very easy, it's like it's very easy. But if you're an outsider, then it becomes, well, the odds are against you. So yeah, try to find a close role to data, to data science, like data analyst or software engineer, and then maybe after a few months or years, you can scale up to a machine learning role or machine learning engineer role or a data scientist role. So yeah, this is a similar thing for machine learning engineer. You need to be having, again, to be honest, communication is also important, because you need to communicate properly in your with your team and your stakeholders as well. So yeah, I mean, these are certain things that you may want to keep in mind. So as you can see, if you're in machine learning or if you're involved in machine learning data science, math is obviously going to be there. So don't worry, these are like your bachelor's level mathematics only, like your calculus and probability theory and your statistics, like regression analysis and so on and so forth. So these things are like things you can learn on your own as well. Okay. Same goes for research. So if you're going to, let's say, academia, let's say you want to pursue masters, you have to be really strong with your research methodology and so on and so forth. So this is a different thing altogether. This is the academic side of machine learning. These all are machine learning engineer and data analysts are applied side of machine learning. Yeah, so I hope it made sense to you, this presentation. And I guess towards the end, I only want to say that if you want to become a data scientist or a machine learning, or you want to break into this field, don't be discouraged if you don't want to do master or anything like that. It is tough. It is meant to be tough, to be honest. And that's how we can filter out serious people from who just want to come in because it's a buzzword. Okay, so it is meant to be tough. You will be slapped a lot, but with each slap you will straighten out a little bit and you will be able to learn a lot. So my only last suggestion would be patient with yourself. Don't be afraid to get a no, and be relentless, because you know for a fact that this skill is going to be in demand for at least next 15 to 20 years, at least, I'm saying. And yeah, with that being said, I wish all the best of luck for your careers, and thank you for attending the session.
Thank you, sir. There is a question in the chat box.
All right, I'll try my best to answer it. Let me stop sharing it.
Hello, hello,
Yeah.
sir. Sir, can you send the PDF? The PDF, the presentation PDF.
Presentation PDF. Just a second.
Keep in group.
In the group, I will send this to the. No, if you want, I can send this to the. I mean, this is a proprietary stuff, so I'm not sure if I can send this to you or not. Well, sure, not a problem. I will send this. What the hell? I want you to do well. So yeah, sure. I'll send this to the official email ID to the team of the organizing committee, and then you can take it forward from there.
Okay, sir. How can take? How can ask to there? How can meet?
I'm sorry, what?
How can take? How can take that PDF?
No, we'll be sending it to you in the group. No worries.
Okay.
Okay.
Sir, actually, there is a question in the chat box. Can you please acknowledge it?
Oh, question in the chat box. Okay. Okay. Question by Venkat. There is one question at least I can see by Venkat, right? So, this is the question you want me to address?
Yes, sir. Yes.
Okay. I'm in third year in my diploma in computer science. So, can I take my UG in AI or can I take computer science? Diploma in computer science I can take. So this sounds like this person is asking me that can I take my undergrad in AI or can I take computer science? So, well, to be honest, if you want to break into this field, right now, I told you that majority of the companies require you to at least have a master's degree. So with that being said, if you plan to continue to, let's say, to plan to to pursue masters, so diploma will not be your best bet. I'm just saying that for what I've noticed. But with that being said, if you can gather sufficient skills like with diploma, I don't see why not. But again, the way reality works is that I know that even with diploma it is possible to gain some skills, but the reality is different of our world, that for some reason companies are stuck with, they are hell-bent on asking for a master's degree. So yeah, I think if you're in a diploma and if you can directly go for masters, you know because there are some universities which will accept 3-year diploma course for a master's as a prerequisite for a master's degree. If you can do that, I think you should do that rather than going for a bachelor's after master's. I mean, that would be my suggestion. But again, if you want, it's up to you. So I hope I answered your question, Venkat. So after your diploma, try to go for masters if you can, if there is a university which will accept your diploma degree as well. If not, we can sure. So coming to in AI, up to you. I mean, AI, in the computer science there is AI, right? So I'm guessing that if you're particularly going for AI, then they will focus more on statistics, probability, and Python, and so on and so forth. So yeah, it depends on you. But if you don't want to limit yourself to AI and you want to explore more stuff, let's say you're not sure though, so maybe you want to have a window open for, let's say, cybersecurity as well, then taking a UG in AI may not be best bet, because that will close the doors for cybersecurity, while computer science is a broad thing, so it encompasses everything, right? So it's up to you. To be honest, computer science is more theoretical in approach. So in UG and AI, I'm guessing that AI thing, whatever university you're planning for, it should be, you have to understand that what is your goal. Do you want to go to the applied side, I mean to the industry, or to the academia? So if you want to go to industry, then I would suggest go for more tailored towards that, what you want to do. Or else you can go for computer science if you want to go into research side, so that you can have more things to explore. Up to you. Again, it's just my opinion. You can change it. Someone else can give you a different answer. You may agree with that person as well. So yeah, it's keep an open mind. That's all I'm trying to say.
Thank you, sir. It was an amazing session. Thanks a lot for sharing your experience on machine learning. Guys, we have planned a quiz for you people. I'll be sharing the link in the chat box.
Sai, Sai Harikrishnan, this is Shivpriya. I just want to
Yes,
talk
ma'am.
with guest. Abhin, this is Shivpriya, and one of the faculty coordinator for this. Abhin, are you there? Abhin?
Yeah, I'm here.
Yeah, this is Shivpriya, who is one of the active, one of the club coordinator, faculty coordinator for this active club, Tech Guyana. And first of all, I would like to thank you for accepting our invitation on behalf of Tech Guyana Club. And I know in this weekend, in this windy weekend, sitting in front of system and explaining these steps is very tough thing. Because it's the early morning for you guys, because 10 o'clock is early morning for you guys because it's weekend, right? And I'm very happy to see you such a Saram product. And we are taking classes on board. And I know how far it will be very useful for the career life, just like a pillar. But support from you, such youngsters, and who is standing at the peak of the mountain. And we are just in the floor of the mountain, and we are just trying to lift up. And you people catching them and bringing them to the top is very amazing thing. And as a staff, I have one question. Can you ask, otherwise, can we suggest any certification for machine learning which will be very helpful to enter into your industry? Is there any certification like that?
Oh, okay. It is very difficult to answer this thing. So first of all, a couple of things that I'm still not at the top of any mountain. I'm still learning a lot of stuff, and to be honest, I'm not even trying to be modest here. I still don't know a lot of stuff. I'm just trying my part to give back to the community and to the university, which actually gave me the platform. So I'm just doing my part. That's it. Coming to your main question, there are certifications, but if, let's say, even from an academic perspective and from an industrial perspective, certifications don't contribute much. I mean, unless you don't have anything in your resume, then obviously put certification. No one is stopping you. I mean, if you've done nothing in your 4 year of college, then put certification, right? So, but my suggestion would be, you can go for certification to learn skills, but companies don't ask for, they don't really care about your certifications. If you look at my LinkedIn, there are 17 or 18 certifications. No one cares for that. What companies are looking for, what have you done with your knowledge? If you have learned some certain skills, good for you. Why should we trust you that you know this? Okay, so you have to demonstrate your knowledge. So the best way, in my opinion, would be, the best way to illustrate that knowledge would be by doing projects and by internships. If you can get as many hands-on hands-on experience, using your skill, that will be hugely beneficial. And in my experience, it actually sets you apart. I mean, I'm a huge believer. I'm a huge believer that the person learns when he's slapped. So doing projects, you will encounter a lot of situations where you were not taught that thing, because certifications cannot cover everything in the world. It is impossible. But doing projects, you will encounter a lot of stumbling blocks, and that's where you will actually use your gray matter to solve those problems, and that's how you will develop your skills. So now, to answer directly your question, if you don't want to do that as well, there are certain courses like on Coursera's, like I did deep learning specialization. Google's there's one certification that is really useful. That is like Google's data, hang on, I guess it's Google's data analytics.
Can you put that course name in chat box, sir?
Yeah, hang on, just let me share my screen and I will show it to you. This is like from industry experts, from industry people only. I've heard that if you want to, let's say, break into data science, This is like the closest thing that you can get with. So Google Data Analytics Professional Certificate, it will teach you, actually it won't cover Python, it will cover R. Okay, so that is like one way to go. So if you have covered this thing, and if you have this on your resume, it's a huge plus point. It's a beginner level, approximately 6 months to complete. So let me put this in the chat window. Even my sister is doing political science from LSR. So she was also asking me how can I improve. So because companies coming to her college is also are looking for economics and more technical skills rather than pol science. So I advise her this only, and this was really huge, beneficial for her as well. So I'm guessing if it is beneficial for someone from humanities side, it is definitely going to be beneficial for, you know, uh, techies like us. And I guess I'm probably pushing this too far. I also have a YouTube channel, with my name only. So sometimes I gave a webinar before also, and I put stuff on there. So if you want, you can check it out as well. So yeah.
Sir, I need one doubt, sir.
I'm sorry.
Sir, I didn't get this quiz link, sir.
Oh, you did
Can you
not?
please put it again?
I put it in the chat window. It again. It's a Coursera professional certificate, Google Data Analytics.
Yes, sir.
I've got it. I hope you got it. So yeah, that was that. Anyway, if you don't, you're not unable to find it, all you have to do is simply you have to simply write Google Data Analytics Professional Certificate. The Coursera link is your way to go, and that's it.
Thank you, sir. Again, it was good asking and clearing doubts from you. So, guys, I have seen like 32 of you have joined the quiz. So, without wasting your time, I'm going to start it. Guys, the game will end in 5 minutes, so be quick. Guru takes the first place as of now. Uh, I think many have completed. Let me wait for 2 more minutes. Okay, now there's a change in the leaderboard. Nehal Mori takes the first place. It's cool, guys. Competition is cool. I'm going to end the game in a minute. So those who haven't completed, please be quick. Okay, guys, now I'm going to end the game. Yes, let's see the winners. The first place is taken by Nehal Mori. Congrats. And the second place goes to Guru. The third place is taken by Arya Sharma. Great work, guys. Yes. Now I have stopped sharing. Now I hand over the session to Miss Chandra, third year CSE CS, to give the vote of thanks.
Thank you, Sai. So I deem it a great honor to propose the vote of thanks to all those who helped us in making this webinar such a resounding success. Firstly, I would like to thank our HOD, Dr. K. Raja sir, for giving us the opportunity to host the event. I would like to thank our speaker, Mr. Eben Verghese, for making an excellent presentation and making this webinar informative, interesting, and meaningful. I thank the faculty coordinators of the club, Ms. Shivapriya ma'am and Ms. Aarti ma'am. I must thank the organizing team, the members of Tech Vienna, for the amount of work they put in to make this webinar successful. Finally, the wonderful students who turned up in such a great number. Thank you so much, guys, for your cooperation. And this brings us to the end of this webinar. But before leaving, I request you guys to fill the feedback form. The form link will be available in the chat box. It's available in the chat box. So you'll be receiving the certificates only if you fill the feedback form. So please fill the feedback form, guys. And then you can leave. You'll be getting the certificates within 2 days. You'll be getting it to your mail. So make sure you guys fill the feedback form.
Thank you, guys. Congrats, Bharat and Rohit. It's a wonderful event.
Thank you, and
All the best. All the best, guys. Congrats, winners. Thank you, guys. Bye-bye.
Thank you,
Thank
ma'am.
you.